Hey, welcome to Build&AI. I'm Nia, your AI learning guide. Let's get into it.
Welcome back to The Explainer. Today, we're diving into a massive, honestly game-changing leap in front-end architecture. We are finally leaving behind those frustrating, clunky DOM manipulation hacks from the early 2010s, the ones that constantly break the browser, and we're stepping into the world of truly professional single-page applications. Let's demystify client-side routing and really master the history API together. Okay, quick look at our roadmap for today. We'll cover the broken SPA problem, traditional versus SPA navigation, the history API, building the router, intercepting link clicks, and finally, handling 404 errors.
All right, let's jump right into part 1, the broken SPA problem, and exactly why the back button fails.
Tell me if you've been here before. Have you ever hit the back button on a web app, fully expecting to just pop back to the previous screen, only to be kicked out of the site entirely? It's incredibly jarring, right? It's literally like trying to step back into a room and falling out of a building instead. This happens when an app just hides and shows sections of the interface using JavaScript, but completely ignores the browser's address bar. From the browser's perspective, you never actually left the very first page you landed on, so clicking back takes you exactly where you came from, off the app entirely.
And that brings us to the non-negotiable rule for professional web apps. I call it the core contract. It basically says, every visible state of the interface absolutely must have a URL that represents it. If you change the view, you've got to update the URL. If you change the URL, you must show the corresponding view. Imagine someone trying to copy a link to share a specific chat screen with a coworker. If the URL didn't update to reflect that specific chat, their coworker is just going to see the default homepage when they click it. This contract is what ensures basic shareability and native browser behavior actually survive in our modern web apps.
So, how do you know if you're actually getting this right? Well, you can use these 4 tests for real routing. 1. Does the URL actually change when you navigate around internally? 2. Does the browser's back and forward functionality work perfectly? 3. Can you deep link directly into an internal view from a fresh tab? And 4. If you refresh the page right now, does it stay exactly where it is? Think of this as a quick diagnostic tool for your own projects. If your answer to literally any of these is no, then your application's routing is fundamentally broken.
Let's move on to section 2. Traditional versus SPA navigation. It really all boils down to who owns the navigation lifecycle.
This comparison perfectly illustrates where the browser actually loses track of things. In traditional web navigation, the browser is the undisputed boss. You click a link, it fires off an HTTP request, the server hands back fresh HTML, the URL updates, and your history is naturally recorded. It's a reliable, totally closed loop. But in a basic DOM-only SPA, JavaScript kind of goes rogue. It hijacks the visual experience, updating the page instantly without a full reload. And sure, it's incredibly fast, but because the URL stays stuck at the root and the history is completely ignored, all that native shareability is just destroyed.
So, to fix this, we have to wire up a brand new lifecycle. It looks like this. First, the user clicks a link. Then, our custom code triggers a programmatic navigation function. Now here's the magic. We use the history API to natively update the URL without triggering a reload. Next, our router reads that shiny new URL and renders the correct view to match it. And finally, the browser's history is accurately updated. This whole process restores that fluid flow where the URL and what the user actually sees are kept perfectly in sync.
Which brings us nicely to section 3. Meet the history API, the absolute crucial bridge between the browser and your code.
Let's look at our first major tool here, pushState. This is literally the foundation of SPA navigation. It lets us change the browser URL without triggering a page reload, and it pushes a brand new entry right onto the user's history stack. But listen, here's the absolute critical gotcha you have to remember. pushState only updates the address bar and the history log. That's it. It doesn't trigger any rendering whatsoever. Your application code is still 100% responsible for actually drawing the new view.
Then we have its sibling, replaceState. Instead of adding a new entry to the top of the history stack, replaceState just overwrites the current entry. Why is this useful? Well, it's perfect for dynamically correcting a bad redirect. Say a user hits an old deprecated URL, and you automatically reroute them to the new one. You want to use replaceState for that. That way you don't pollute their history stack with some broken, intermediate step that they'd otherwise have to click back through.
And finally, we have the vital popstate event. Whenever a user clicks the physical back or forward button on their browser, the browser fires this event. It's basically the browser shouting at your code, "Hey, the user just navigated." This is your explicit signal to manually re-render the view based on whatever the new URL happens to be. Now, the golden rule here? PushState and replaceState never ever fire the popstate event. It only happens on native history navigation.
When we map all these interactions out, this really clear logic matrix emerges. It's basically your cheat sheet. Notice how programmatic actions, like calling pushState or replaceState, require us to manually call the router to render. But user actions, like clicking back or forward, rely entirely on our popstate listener to trigger that view update. Pinning this logic into your mind is huge, because crossing these wires is literally the #1 cause of out-of-sync bugs in modern web apps.
All right, moving into Section 4, building the router. Let's break down the 2 core functions you need.
First up is the router function itself. Think of this as the decision-making core. It's the traffic cop of your application. Its whole job is to actively read the current state of the URL, specifically the window.location.pathname, look it up in a central route table, and then execute the specific function that builds the interface for that exact path. Every single view change has to eventually pass through this traffic cop.
Second, we have the navigateTo function. Remember how we established that pushState has absolutely 0 visual side effects on its own? Well, navigateTo acts as the vital wrapper for our programmatic navigation. Inside it, we first call pushState to update the address bar, and then we immediately manually call our router function to actually paint the new view onto the screen. You absolutely need both of these working in tandem.
Now, I want to issue a strong warning here because this is a very common trap. Do not duplicate your routing logic. It's super tempting to put an if URL equals X render Y statement inside the navigateTo function and then write that exact same logic all over again inside the popstate listener. But doing that means every new route you add requires updates in 2 separate places. Instead, use your single router function as the solitary source of truth for all rendering decisions.
Okay, Section 5, intercepting link clicks. We've got to preserve native web behavior here.
It's really tempting to just take a sledgehammer approach to your links. Just write a script that finds every single anchor tag on the site and slaps an event.prevent default on them so your SPA router can hijack the whole show. Please don't do this. It's a massive anti-pattern. If you block all native link behavior, you strip away basic web accessibility. You break the user's ability to control-click or command-click to open things in a new tab. You break the right-click menu. And worse, you'll accidentally trap users by intercepting external links that were actually meant to leave your site. It just creates a deeply frustrating experience.
Instead of the sledgehammer, use selective interception via event delegation. By setting up just one single-click listener on the entire document, you can check exactly what kind of click just happened. Was it a normal left click on an internal path? Great. Intercept it and fire navigateTo. But if the user is holding control or command, or if the link has a target_blank, or if it's pointing to an entirely different website, we have to let it pass through normally. This approach gives you that blazing fast SPA speed while totally respecting standard HTML semantics.
Finally, Section 6, handling 404 errors. Let's look at the internal and server-side edge cases.
It's really essential to understand that we're dealing with 2 totally different types of 404s here. An internal 404 happens when your SPA fully loads, but the user navigates to a URL that just isn't in your route table. The fix there is simple. Build an internal fallback view that politely tells the user the page doesn't exist. But a server-side 404, that's completely different. That means a user refreshed the page on a deep route, like /chat. The server looked for a literal chat.html file, couldn't find it, and threw a generic host error. Your SPA never even loaded. The fix for this actually happens outside your code entirely. You have to configure a catch-all redirect on your hosting platform, like Vercel or Nginx, to always serve your index.html file, no matter what path is requested.
So to pull this whole shebang together, initialization order matters immensely. When your SPA boots up, you want to follow this exact sequence. First, set up your link interception so any future clicks are instantly captured. Second, attach your router function to the popstate event so that native browser navigation is fully covered. And third, call your router function directly to read the current URL and paint the initial view. Nailing this sequence guarantees a flawless boot up every single time.
We've covered a massive amount of architectural ground today. We've gone from those broken, frustrating DOM hacks all the way to a fully functioning, professional, single-page application router using the History API. So I want to leave you with this final, somewhat provocative thought. Take a hard look at your current web projects right now. Does your application truly honor the core contract? Does every single view have a URL? And does every URL consistently render its proper view?
I challenge you to audit your work with this newfound clarity and go build some better, unbreakable applications. Thanks for joining me.
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.